Hello. Sorry, testing my mic. But I am about to start. Oh, there we go. I can see the chat, so hopefully I keep this on screen so I could keep hearing all you guys. Alright, my mic seems okay. Hopefully it's picking up the microphone. I think it is. Hey guys, I'm just about to start, so good timing. Have your mic on, turn away from the computer. Alright, Prem, I'm gonna have you let me know. Can you still hear me okay, Prem? Actually, yeah, the mic is on. Alright, more tests. Sorry, technical difficulties. Media source, properties.
We're talking about randomness today.
Yep, randomness.
What is randomness? Does it exist?
That is part of the presentation.
What a random thing to say.
Yeah. I don't know if I'll be able to get this microphone working. Mic, aux. Not sure how I got it to work last time. Settings, surely. I'm not like all that great with OBS, it seems. Do you know how to use OBS? Michael, you're like a superstar now since
Windows.
you're streaming.
On Windows like 6 years
Okay.
ago.
What are you trying to do?
I'm just trying to get my mic picked up.
Do you think HDMI audio is stealing the thing?
Here, I'll reconnect it.
Maybe go to audio devices, like hit the search bar and
Search bar?
yeah, like on the Mac OS stuff.
Oh.
Type like MIDI. It's like MIDI and audio. Yeah, audio MIDI setup. And like disable or enable, like disable everything except whatever you want. That's what I kind of do.
Just the default microphone here. But
So
this
which
thing's
one is
also
yours?
not really lighting up. This thing is supposed to. Whatever. I guess the microphone might not be that important. Because it doesn't seem like it wants to work for me today. I'll try one more time plugging it in. Okay, it lit up.
Did it show up in the list?
No. And I want the audio to sound good, and I feel like this should be an easy thing. It's just not. No, I have a mic here. I'm having trouble actually getting it to.
Is it just OBS not seeing it, or is it the computer?
I'm not sure how to switch it. The mic. I'm like, remember doing it last time. Yeah. I don't know how
It
to.
doesn't seem to show up in the operating system. for some
Try
reason.
to turn it off.
Yeah.
Oh, maybe you need like device drivers or something.
No, I've like used this before.
Oh.
That's why it's very frustrating right now, because like I know I've done this before.
Maybe it's just broken.
See, advanced audio properties. Watch. And you'd think that they'd have a mic selection here, but they don't.
Yeah, I found out that mine won't work with my phone.
Oh, never mind. It's right here. Okay.
There you go.
Wireless microphone. Yeah. All right. That was 5 minutes of debugging. Okay, I still sound okay. All right. Thanks for bearing with me for the sound. Welcome to Understanding Bitcoin Source 21. It is going to be the last in the series, at least for now. This is going to be either the end of season 1 or the end of the series. I haven't decided yet, but welcome. Today, we're going to talk about randomness. All right. So what is randomness? Can I have some answers from you guys? What do you think?
Well, you cannot derive the sequence.
Okay.
Will occur in the future by knowing anything.
Yeah, unpredictability, some unpredictable source.
That's a better word, yes.
Okay. Any other, answers to what is randomness?
Non-repeatable,
Okay, yeah, something that it doesn't repeat, or at least doesn't repeat very often, because if you have a uniform distribution over a large enough range, then you won't see the output uh, repeat itself too often.
Like any sequence of the outputs, or like just any character? I guess.
I mean, we're thinking like of a sequence. Think of a transaction ID, or like symbolically you could have like these letters, but they represent in hex, but they represent this huge number. So even if you have, shared bits between two different, like byte strings or bit strings, it doesn't mean these two things are that closely related. But yeah, what is randomness? So to help answer this question, I took some musings from Reddit with proposed definitions. And actually, I will keep this chat open, which I realized I minimized. Much better. Yeah, it's a Bluetooth mic, Prem, and I connected it. But I see you posted that a couple minutes ago. So yeah, the music's from Reddit. This is something I upvoted. You can buy a USB stick RNG based on avalanche diode noise for $50. A far more expensive method is to measure my wife's time in a shoe store in integer hours. So like, yeah, I just thought it was funny because it's exhibiting the concept of unpredictability. And this guy's talking about his wife's time in a shoe store. And of course, random. And this is some post about randomness. And then there was this back and forth about randomness within this thread, and I kind of like this answer, where this guy was pointing out to someone else that one of the participants of the argument was saying there's no evidence there's ontological, that is independent of an agent's information, randomness, as opposed to epistemological, that is based on information an agent has, randomness. So when we talk about true randomness, we're speaking colloquially about the practical impossibility of acquiring the information that would enable predicting an outcome. For most purposes in computing, relying on dev random or its moral equivalent is good enough. So this answer was saying randomness is something that relates to humans and what we're able to know. No one knows if there is an objective randomness. No one knows the limits to predictability that we have of the universe at large. And I thought this demonstrated that pretty well. So I also have the Oxford Languages definition of what is randomness. Oxford Languages defines randomness as the quality or state of lacking a pattern or principle of organization. This scopes randomness as to be defined as what is outside the collective human ability to recognize, but can this ever truly be defined? So going back to this philosophical concept of what randomness is and if it can be defined. And I'll talk a little bit more about that, but I think this is a good definition to work off of. The quality or state of lacking a pattern or principle of organization. So what are reliable sources of randomness?
Lava lamps.
Lava lamps, yes, that is a reliable source of randomness, and I'll go into that too. Any other suggestions for randomness?
100 dice rolls.
100 dice rolls, you get pretty good randomness from that.
I think can't you get randomness from radio waves?
Yes, yeah, from radios. You can also get randomness from. You have any input for what are reliable sources of randomness?
Time.
I mean, for randomness, it's typically not desired to use time for things, which I'll go into a little bit as well.
All right. Time.
I mean, it could be used as like a source, I guess, to mix in. Yeah.
There's an IEFF or something like that standard on how to generate a random number.
Yeah, there's all these different algorithms for generating random numbers, and I have like a couple of them in this slideshow, but physical ways to measure randomness are typically the best. And you take whatever physical source of randomness and try and digitize it, and that seems to be the way to go about things. So I just put 3 examples. What are reliable sources of randomness? One is the NIST random beacon, if any of you guys have heard of that before. There's random.org, which gives pretty good randomness. And then there are the Cloudflare lava lamps, which Leron was mentioning not too long ago.
The actual lava lamps.
Yeah.
Yeah.
They have a wall of them, and they have a camera sitting in front, like facing them. And that's how they generate randomness effectively. Is whatever picture it is, the pixels at that moment. And
It's
even
like
if
hashing
people walk through, like between
Yeah.
the camera, that's even more. So they're off.
Yeah, and it's a pretty reliable source of randomness. So, NIST Random Beacon. This is a service that sources randomness data from hardware devices that measure a process nearly impossible for us to predict. Applications that would like to build on this random beacon can make API calls to retrieve the random bits they provide. And I think it's funny that this says do not use beacon generated values as secret cryptographic keys. They scope how they would like to use their randomness. And I think a lot of services do this that provide randomness. They say use this for non-critical applications. And
Does that mean it's not actually random?
it doesn't mean that it's not random. It maybe means that they are not confident that they are the most efficient way to gather randomness. And there's also like a concept called like a cryptographically secure pseudo-random number generator, and that is the type of algorithms you use for cryptography, for encrypting things. And you could have a really good pseudo-random number generator that really hasn't been signed off as a cryptographically secure one to use for those type of applications. And I have this little bit about the NIST random beacon. The randomness of a beacon must result from the combination of at least 2 certified sources of cryptographic randomness. The NIST randomness beacon will incorporate a 3rd source using randomness obtained from a quantum process related to probabilistic detection of photons, which is, again, one of these weird physical processes that help give unpredictable outputs. The device was developed by Joshua Bianfang and Michael Wayne's team at the NIST Physical Measurement Laboratory, which also participates in the NIST randomness project. And you can see these cool devices here: power supply, randomness calculator, quantum RNG. Again, quantum, I think it makes it sound really cool. Photon counting detector, and exterior and the interior view. So another one, a good source of randomness, is random.org. The technology for this site was first used as a source of randomness for a gambling application. So the guy who made random.org, he didn't set out to make a website for generating randomness. It was to assist an application he was developing for gambling. And he said, gambling is one of the things that you don't want to get wrong, especially if you're the house and you want to make money off of it and someone's gonna game you by predicting the randomness that you generate. So it was a vital part of making a gambling application.
Very trusted.
Random.org? In a way, but there are statistical tests you could do for randomness to see, like how random something actually is. I mean, statistical tests are probably the best measure you could use, and they do use statistical tests on their end, but you could also do that with the data they provide to, see if it matches the properties of something random at least.
What if that's how we discover aliens? Is those cameras pick up some sort of like rhythm or signal or something? So that noise.
Yeah, maybe understanding the pattern will help us. Yeah. Yeah, but then you break randomness, and then a lot of cryptographic algorithms are gonna be weak, and all our information is gonna be stolen. so it's good to at least have one thing that you can't identify the pattern for.
So are these are better than cryptographic algorithms, like the ones that are
they're not better. They're like used in conjunction with cryptographic algorithms. So any cryptographic approach to generating random numbers typically requires a seed, and that seed you want to be like some proxy of like randomness, and a lot of these methods are actually used to generate a seed. Yeah. And yeah, I don't really go too much into this in the slides, but stream ciphers are essentially some predictable randomness from the person who has the seed, such that like you can keep making a random stream of information they can XOR with the message to encrypt it with. So that was like the basic idea of stream ciphers. But yeah, randomness is very important. That's what I want to say with that. Yeah, the team needed something better than the pseudo-random number generators at the time, which is 1997, and decided to use radios which picked up atmospheric noise. To actually get a correct amount of randomness, they had to get the cheapest radios with the weakest noise filters. So at the time, they went to Radio Shack, and they said to actually pick up atmospheric noise, we don't want the noise filters that would actually help our signal like get picked up better or like send better. We want the cheapest radio that just does not try and filter anything. So I went to Radio Shack and they tried out a whole bunch of these radios in the store, and they were able to pick one that matched their needs. But the gambling project died, and the project continued. And today they use multiple nodes, each with their own radios that have their own output subjected to statistical tests before being served through a cloud pipeline they have, so that you could query their randomness through an API. So they're a pretty good source of randomness. And here we have the Cloudflare lava lamp. Cloudflare uses lava lamps as sources for randomness because the position of the lava, those little circular kind of polygons in the lava lamp is unpredictable. To digitize this data, Cloudflare takes pictures of 100 lava lamps hosted in their lobby. I don't know if it still is, but it was at one point. They have an article about it, which I link over here. To source their randomness, they take these pictures and use the pixel values, and they take that seed to then put in a cryptographically secure pseudo-random number generator. So again, sometimes you just use these sources of randomness to have seeds that you could use to pass into these cryptographically secure pseudo-random number generators. Lava lamps aren't the only source of randomness, and the data generated by the Linux operating system will be discussed later in this presentation. So I'm talking about this little snippet here. Are the lava lamps the only source for the cryptographic seed? And here it says, many operating systems have their own sources of random data for use in cryptographic seeds. For instance, from user actions, mouse movements, typing on a keyboard, etc. Although they obtain this data relatively slowly, because they have to wait, on a human. Cloudflare mixes the random data obtained from the lava lamps with data generated by the Linux operating system on 2 different machines in order to maximize entropy when creating cryptographic seeds for SSL and TLS encryption. And I do go over what that means to be generated by the Linux operating system. Just a little bit. So if our technical achievements may be able to predict what we perceive as random today, is it true randomness? Again, this philosophical question of what is randomness and what isn't. But a good effective definition is just some source that can't be predicted by anyone in the world.
We live in a simulation. There is no true randomness.
Yeah, right. Yeah, but again, from like a knowledge perspective, what we're allowed to know, even in a simulation, we can have randomness. We just need an adversary to not be able to identify a pattern in the thing that we're using to keep data secure, right? And I like this. So these are the lava lamps. And I always forget this guy's name, but I've watched a lot of his videos. And he made a video about Cloudflare and their lava lamps. And there's a quote from it I liked that he said, which is, whether anything in the world is truly random is arguably a question of philosophy and not science. Some people think if you had all the variables in the world, you could predict every single thing that happens. If I knew the atoms in your brain and how they interact and there is a way to know everything. And some people think that there would never be a way. And quantum mechanics are the root of or at the root of what we can't understand. But we'll see. So for computers don't have access to photons, atmospheric data, or lava lamps, how do they generate randomness?
You mentioned mouse movements, random files,
Yeah.
things like that. I know. I think it's UBP. I don't remember at this point, but one of those kind of things. When you set up certain things, they'll have you move your mouse around
Yeah.
for like a minute, and it actually won't continue if it senses that you're not moving your mouse around.
Yeah.
Forces you to.
Yeah, and maybe one thing about those mouse movements are that sometimes when they source the data from these places, maybe the way that you jiggle your mouse is
Not random.
right. Yeah, is not random. But if you're taking like pixel perfect precision, and your screen has the resolution for this, and a lot of screens do, you could start taking like the decimals of this position, the equivalent of that, on your screen, such that there was no way for you to intentionally move to that specific position. So if you have high enough precision about like where your mouse is, you could start taking information that would be impossible for you to target, as a human. So I thought that was kind of interesting. I should have included that too, but I read that somewhere. So even if your patterns of moving your hand are not random, the positions you end up in can never be the same as someone else. Or it's very hard to get an exact movement and position.
Can you remove randomness from a system?
Um,
Like if you have the lava lamps running, you could hack into the thermostat and make it all really cold.
Even then, the physics behind the motion of the lava lamps are very hard to calculate and predict towards the future. So, but maybe a easier thing to do is just put a false image on the camera, and have the same lava lamps shown. Somehow you're able to
Maybe a better
slap
example,
something.
Like, lava lamps are going, but then a person stands in front of them, and
That's also randomness. Yeah.
But what if you keep going like this back and forth? Then you know that this the whole instead of having all the pixels be random, you could reduce the randomness by
Or
making these
blocking
pixels
a lava
here.
lamp, maybe.
Yeah,
It also depends on the precision of your camera. So
Position of the camera and how much of the overall, the wall's pretty big. So
Right.
how much of the overall wall are you taking into account?
yeah, and if you block 5 lava lamps, maybe you're still okay. And in how many other sources of entropy that you're taking as well. And remember, Cloudflare takes other sources of entropy, of randomness, than just using the lava lamps. Okay, any other guesses before I go to the next slide about how computers generate randomness at home or on your phone?
Is that random files, having you put random files in a bucket of sorts? I've seen that before, but that's more to protect against the software, I guess, or maybe not. But yeah, because 2 different people are not going to have the exact same files.
Right.
Probably. On their computers. What else have I seen?
I mean, I could go to the next slide anyway, and maybe relevant but still somewhat irrelevant is recently I was looking at this bug that Bitcoin. Well, it's not really a bug. It's something that Bitcoin had, and this has something to do with randomness because you get a lot of this random output with respect to block hashes and transaction IDs. You don't really know what they're going to be, right, when you hash things. There was a time where a file in a Bitcoin directory was being flagged by an antivirus, and certain files were being quarantined away and breaking people's Bitcoin nodes. And what they decided to do is they said, okay, let's try and make this just slap another source of randomness on this, because the history of our blockchain of our data has resulted in this antivirus software being able to flag things. Hey, how's it going? Welcome. Yeah. 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 Yeah, feel free to plop down anywhere. There's, yeah, sure. Yeah. So yeah, just talking about randomness. It's kind of like Socratic style. So like, feel free to interrupt, ask questions, and all that. So yeah, any guesses? And I kind of asked you guys what the computational source is. Yeah, and no, it should not be sourced by the user. With respect to randomness, you don't want randomness to just be provided by the user. Maybe it's a source of randomness and you put it through a cryptographically secure or pseudo-random number generator, but typically when you're generating randomness in any computer system, it can't just be sourced from a user's action. And yeah, I thought this snippet was pretty funny. So this was written, by someone who was talking about the security of randomness, and they said, as I've alluded to with the title of this post, humans are notoriously terrible at creating randomness. For example, if I asked you to choose a number between 1 and 10, statistics show about 30% of you will choose 7. There's an excellent chance everyone will choose an integer and not something like 3.8643, even though I didn't specify you had to select a whole number. So then what makes a number random? Strap yourselves in. Things are about to get wild. And it's a whole other article if you're interested. There's this QR code. But she was just trying to demonstrate, with that paragraph that humans choosing things at random aren't very good. So, which is why it's never recommended to choose your private key, for Bitcoin. You don't just want to randomly guess at what should be a private key, or even like mnemonic, your seed phrase. It's very ill-advised to go and write down words that are acceptable in what you think is a random order, because a lot of times what you think is a random order is not. So I wanted to cover 2 bad ways that computers can generate randomness. I mean, there's so many more ways than those 2 that I listed, but they are related to Bitcoin projects, so I included them in here. Yeah, bad ways to generate randomness: the linear congruential generator and this certain flavor of the Mersenne twister. So have any of you guys, heard of any of these 2, algorithms? The second one, maybe you have in context of the vulnerability, but I'll go to this first one. So the linear congruential generator, LCG, this was apparently popular back in the day with many pseudo-random generators using this algorithm as the standard. So I first learned about this algorithm in Dan Bonnet's book. He's a cryptography professor at Stanford. He has like a free book on cryptography. I haven't read it cover to cover, but I did remember seeing this and I was able to recognize it. And eventually it was found that there is a bias in the outputs of the LCG that can be leveraged by mathematical methods to calculate the seed. And although I would like to show you the algorithm to generate like these pseudo-random numbers is actually not very hard. It's a very simple one to see and understand. Although the reason why it's insecure is a lot harder. It involves linear algebra and lattices, which I know nothing about, to prove why it's insecure, but it is. And this algorithm was used in a library called JSBN, which is JavaScript Big Numbers, that Bitcoin.js depended on before March 2014, and now makes all the wallets generated before that date vulnerable to attacks that modern Bitcoin.js wallets are resistant to.
Do we know if anyone's ever exploited any of those?
I don't think so. So yeah, if you know any projects that were using Bitcoin.js at the time, and you are a somewhat malicious actor, you could probably try and brute force some private keys and steal people's Bitcoins. Yeah. And bugs like these, it's funny because I have a couple friends and they have a lot of money in Bitcoin, and sometimes they tell me that they haven't moved their Bitcoin in like 10 years and they might be using some super outdated wallet or use some outdated wallet. And I'll go through some vulnerable software versions of Bitcoin wallets, but a lot of times, especially if you're there really early, and which is funny because those are the people who have the most money, like millions, they might be using a wallet that is very insecure, and you should probably check to make sure whatever you have your $10 million of Bitcoin in doesn't have like a huge security flaw. So, Yeah, and this is the Bitcoin like JS vulnerability. Again, there was like a library they depended on, and that library used this thing called secure random, and it had like this weird thing where if you're using Netscape and all these things were true, then you'd use window.crypto.random, which actually isn't too bad to use. But if you didn't hit this if statement, then you'd like use math.random, which isn't like a super secure way to generate randomness. You know, any JS dev will tell you that these things have bias in this.
And is that loop and stuff? Is that algorithm that you were talking about, or
No, I have no idea what what this one is. Yeah, it's just something that I used, but something that you could like easily see in brute force, because the biggest source of randomness here is the math.random. I mean, there is some randomness with this process, but it's still, you know, not secure, and people can brute force these sources of randomness. And again, I had this is a snippet from the book. Linear congruential generators are used in statistical simulations to generate pseudorandom values. They are fast, easy to implement, and widely deployed. Variants of LCG are used to generate randomness in early versions of glibc, Microsoft Visual Basic, and the Java runtime. While these generators may be sufficient for simulations, they should, in italics, never be used for cryptographic applications because they are insecure as PRGs, pseudorandom generators. In particular, they are predictable. Given a few consecutive outputs of an LCG generator, it is easy to compute all subsequent outputs. In this section, we describe an attack on LCG generators by showing a prediction algorithm. And then, you know, that's when he has his whole proof that was too long. Basic linear congruential generator is specified by 4 public system parameters, and you know, it's more of this math stuff. But it's insecure. That's like the main takeaway. So if you use an old wallet that relied on Bitcoin JS around that time, you should probably transfer your funds. And then the Mersenne twister is used in the MilkSAD vulnerability. And how many of you are familiar with MilkSAD?
the name is very familiar?
Yeah, so remember the Eric Vescoli thing?
Oh, was that?
Yeah, I think he's the one who made that, like, you know, lib Bitcoin library, I think it was. So yeah, and it was what featured in Mastering Bitcoin as an example of how to generate like keys and your seed and everything. So it's this library that used this thing called Mersenne twister. Mersenne twister is vulnerable to attack. Yeah, it's a vulnerability found in the lib Bitcoin library and outlines the insecurity of the Mersenne twister PRNG, which has been used in different ways in wallets over the years. So it was also, do I have it the next slide? No. I'm surprised I didn't add it, but it was used in Trust Wallet as well. It was, the scheme that they used with Trust Wallet was a little bit different, but the vulnerability or the method of attack was the same. So Trust Wallet revealed that they lost $170,000 of the users' funds, but it could be more. And they did reimburse people, which I thought was kind of like interesting and funny. But they've had like a whole bunch of other issues too. I don't know if I'd ever trust Wallet. Or some people take the like opinion that if you mess up a whole bunch of times, then you start learning all these mistakes. But maybe there's like a certain level of mistakes or frequency of mistakes that you're like, okay, like I still don't trust that the next iteration won't be just around the corner. So you know, I don't like to tell people what wallets to use, but maybe you should reconsider if you've ever used Trust Wallet, moving to something more secure. So this vulnerability, again, this flavor of the Mersenne twister pseudorandom number generator was incorporated in the description of this vulnerability, this disclosure of MilkSAD, because the seed phrase generated with libbitcoin at time 0 started with MilkSAD. So libbitcoin also sourced like the randomness with time, and it was time and the Mersenne twister, and it was just something that was very predictable. You could put a whole bunch of timestamps in there, and you could brute force the space pretty quickly, and somebody did, unfortunately. So the catastrophic loss resulting from this issue was immense. So we attribute these to one well-prepared actor. The researchers who disclosed this didn't have time to try and break all the wallets that they could. So they just focused on like only looking at the Bitcoin, blockchain, and just a few big examples. And they found this one well-prepared actor who stole around 29.65 BTC worth, upwards of $850,000 in Bitcoin alone. 2023 exchange rate. We think it's likely this actor also carried out theft of other coins in the same day. So someone figured this out, and I guess they're auditing these randomness libraries, and they said, oh, maybe there's a way that I could steal some Bitcoin just because people didn't source their randomness well. And this person did, and this person is a millionaire from it.
Well, they haven't moved the coins. They're technically not.
Yeah, as of August 2023, he actually lists the addresses on the website. So like hopefully an exchange blacklist or something. But it's also hard to blacklist because you could say, oh, it was actually my coins and I moved it because I found it was insecure, even though it wasn't disclosed. Which is, yeah.
But they can still send it to like a mixer or something, right?
Yeah, they could send it to a mixer. I mean, it's a lot of Bitcoin, so you'd have to have like a good amount of liquidity in that mixer. And if you don't, then sometimes they can still track you after you mix it. Like, I think I showcased Chiptune. There's another mixer that someone put a couple billion dollars into, and since they like flooded it with liquidity, their privacy guarantees weren't as strong as if you had like a small amount of money. Or maybe it's just Chip Mixer. I don't know. One of these, like,
I think that's a problem in many of them because you don't have enough other people to join
Yeah.
with, right? So you're gonna end up.
Yeah, especially if you have like a lot of money like this.
I know that there was a time, obviously things are very different now, but there was a time where one of the reasons Wasabi was so popular is because they had the most liquidity by a lot when it comes to like Wasabi versus Samurai type of thing.
Yeah.
That changed, I think. Don't know exactly, but I know that like even if you wanted to use Samurai, but you had a lot of Bitcoin, you really couldn't, and Wasabi was your best bet, I think, at that point.
Yeah, Samurai, I could see people wanting to stay away from it in favor of Wasabi because of liquidity. And it was also just easy to use, which probably added towards this liquidity that people were able to hide in, privacy-wise. But yeah, pretty big number. And then I wanted to go over some good ways computers can generate randomness. So good ways to generate randomness, /dev random and /dev urandom. A hashing algorithm like SHA-256. Again, like assuming that your seed is secure. So like even then it's, somewhat a good source. Or some people say like mining Bitcoin, right? Like when you are finding a nonce for a Bitcoin block, you don't know what that nonce is going to be beforehand. So whatever block hash ends up allowing you to meet the target will have this quality of randomness to an extent, right? Like if you still have a target. So and if you know that you have to hit below some target, then that like somewhat limits your randomness. But the range of these numbers is so big that it still gives you pretty.
Yeah, I was talking to someone that's working on some, like mixing type of technology and like decentralized, where you don't have to rely on a coordinator, and they were using pretty much the latest block or something like that as a source of randomness, so that no participant can kind of cheat as far as who gets included in the next round. It helps like choose that.
Yeah. The block hash, I would say, is a pretty decent source of randomness. Once you kind of take into this account this fact that they have to like look for this nonce. They don't know what the nonce is going to be beforehand.
You can use. I know you were saying that the hash itself may not be because of the difficulty thing, but the nonce is more random, probably.
Yeah, well, the output of like any cryptographically secure hash function will be randomly like distributed. So like people still aren't like they don't really know what value they're gonna get. The nonce could also be like somewhat random, but I'd say like you can get, or I would think that the output of the hash function
Is
with
providing more random.
Right. Yeah, it's more uniformly distributed because I could, or 80% of the industry could be searching for the nodes, from zero, like monotonically increasing, or within this range. So there's like a lot of factors to it. And then Cha-Cha 20. I don't know if any of you guys have heard of Cha-Cha.
I know I don't know the intricacies, but
Yeah, it's an algorithm that's used as part of the Lightning Network, protocol. So, and dev random and dev urandom. Anyone ever hear these two? So these are treated as like files on Linux, or like everything's a file descriptor on Linux is the joke, and source random data from multiple device drivers, like a network router that receives traffic sporadically. So it tries to take from a whole bunch of different sources of entropy with respect to your device drivers, maybe how hot something is running. And the random data sourced from drivers is then fed into a hash function, Blake2, and passed to a secure random, a pseudo-random generator, which is Cha-Cha 20 based at the moment, the same algorithm that Lightning uses in stream cipher Cha-Cha 20 poly 1305, with this poly 1305 being something that you use for integrity, like message authentication code. So Macs have these files, but randomness is generated different than how it is on Linux. So like, you could have things like a secure enclave, hardware interrupts, and all these tiny things that might differ on your computer versus somebody else's. So this is kind of like the de facto way that you can source randomness on Linux-based computers. Dev random and dev urandom. Or really dev like urandom is the one. I forget the difference. Did I put something?
unsigned, I think, right? No.
It's not just that. It's about like initialization. So like one, you can use like fresh out the gate without giving it much time for initialization, and that makes it like a little bit less secure. Or that one's dev random, because I know dev urandom is like more secure because there is like some startup time where it needs to go collect information from sensors, and this is the most secure way to get it. But if you needed it for some purpose, right when your computer booted up, and depending on what you're using it for, dev random might be good enough. SHA-256 backtracking resistance. I think I wanted to put this after, or yeah, I guess this is included in my SHA-256 randomness generation. So SHA-256, I said about Bitcoin blocks that they use it to go hash, like those block headers, and you get pretty good randomness from it. But there are certain things that you need to be aware of. This mentioned something called backtracking resistance. So he said, one gotcha with this setup is reconstructing past generator states when the current state is compromised. Under a compromise, you would have the secret X and know the current counter iteration. Decrementing the counter will give you all prior states. This isn't optimal with cryptographically secure RNGs where we want backtracking resistance. So one important thing to think about is whenever you use a seed for randomness in a cryptographically secure random number generator, or cryptographically secure hash function, is you don't want to keep using the same seed and like something that's predictable. Like if you use the same seed, let's say I used the word Bitcoin and I had like a counter that said 1, 2, 3, and the hash function might output something that's across the uniform distribution with Bitcoin in 1, and Bitcoin in 2 is going to be completely different than the output of Bitcoin in 1. But if somebody were to find out this seed of Bitcoin, and they knew my scheme of putting numbers right after it, then you're at risk of having all of your previously randomly generated numbers be exposed and replayed. So that's what this person was kind of saying, that there's a way for you to use this initial seed to generate another seed in the next iteration of hashing, so that you don't have the same seed every single time and just a counter that's predictable. So yeah, backtracking resistance is what they call it. So you have to be careful when you use things like SHA-256. Generator is compromised. The prior states cannot be recalculated without breaking SHA-256. That's achieving backtracking resistance. Maybe another thing I want to note about hashing algorithms and using cryptographically secure hashing algorithms for randomness is that they can generate randomness in this sense, just like SHA-256, but you have other algorithms, maybe like Cha-Cha 20, that are actually more efficient when generating randomness. So SHA-256 isn't used in many cases because other algorithms are optimized for creating randomness and don't require maybe all of the things that SHA-256 does as a secure hash function, which are things like preimage resistance and like collision resistance, and so on and so forth. Yeah, CHA-20's emergent use as a PRNG. So CHA-20 is something they used as part of a stream cipher, which I mentioned before a little bit earlier, that stream ciphers are essentially ways to generate pseudorandom output that you can export onto some message traditionally. And CHA-20 kind of like used this general structure to be a stream cipher. And there is a way that you could turn it into a pseudorandom number generator. And this is a post from this CHA-20 RFC. CHA-20 could be used as a key derivation function by generating an arbitrarily long key stream. However, that is not what protocols such as blah, blah, blah require. So, it wasn't in this, towards the same purpose that this CHA-20 spec was describing. The author made another post about how to make CHA-20 a pseudo-random number generator. I think, yeah, okay, it's in the next one. Yeah, for this reason, this document does not specify a pseudo-random function and recommends that crypto suites use some other pseudo-random functions such as PRF, HMAC, SHA-2, 256. So they were saying, do not use CHA-20 as a pseudo-random function because this is not what it was made for. At least like in this RFC, they were trying to say that. But then the author went and he has like this obscure blog. Well, I don't know if it's obscure, but like it's a very like basic blog. If you actually look at it. In terms of like the design, it looks like something that someone put almost no effort into. It's just like HTML page, And here he does talk about using his algorithm CHA-20 to be a pseudo-random number generator. So here he goes, there are also similar new functions, crypto RNG salsa 20 and crypto RNG CHA-20 using my salsa 20 and CHA-20 stream ciphers. So he does like kind of acknowledge that there have been secure random number generators generated from his stream cipher.
Really into dances.
Dance? Oh yeah, cha-cha. Yeah. And actually, I think it was like salsa was used in like a version of TLS, and I guess maybe they found some vulnerability, not with salsa. I think it was like how they're using salsa, and Google switched to CHA-20. They were one of the first people as part of their TLS like implementation, even when others haven't vetted CHA-20 as much. So some people in the industry were saying, oh, that's like really weird switch. But fast forward now, like years later, and CHA-20 like has been proven to be secure, at least in the application sense, because it has been broken. Again, it's used in Lightning, so it is super important even to Bitcoin technologies. And bad randomness is not always just about using a secure PRNG. It's how you use one, which is what I brought up with that TLS implementation example. And there is a way for you to use something that is a cryptographically secure random number generator, but you have some scheme that like makes the output predictable. And that is just like using something that is good in an incorrect way. So there are like foot guns pretty much, right? And one of the examples here, I might want to open up like a page about this, but the Android security team has been investigating the root cause of the compromise of a Bitcoin transaction that led to the update of multiple Bitcoin applications on August 11th. So, August 11th was a sort of a D-Day for a whole bunch of these Android-based Bitcoin wallets. And
Like Android apps? Like
huh?
Android phones?
Yeah, this is back in, like, I think 2013. So, yeah,
Wait,
no, not recently. Yeah, I'm sorry. Yeah, I should have specified that because we're in August. It's yeah, this was a while ago. Yeah, a while ago. But if you have a wallet from 2013, some people are like, I have an air-gapped phone. Mine's from 2013, it never hits the Wi-Fi, and like that my wallet is okay. Well, if it is not okay if you used a wallet again that was on Android 2013 or before that, because you have this vulnerability. And this vulnerability was, we have now determined that applications which use the Java cryptography architecture for key generation, signing, or random number generation may not receive cryptographically strong values on Android devices due to improper initialization of the underlying PRNG. Again, this doesn't talk about an insecure pseudo-random number generator. It's talking about a flaw in the initialization of this pseudo-random number generator. Again, going back to this concept of like a secure seed, even if you have some type of algorithm that can produce random looking output, you need to initialize the algorithm with some smaller source of randomness, which is a seed in most of these cases. And if your seed is compromised, then all of your outputs using this pseudo-random number generator are going to be compromised. And this is what happened with the Java cryptography architecture used within like Android devices as application. And applications that directly invoke the system-provided OpenSSL PRNG without explicit initialization on Android are also affected. Applications that establish TLS SSL connections using the HTTP client and Java.NET classes are not affected, as those classes do seed the OpenSSL PRNG with values from dev urandom. So there were a whole suite of applications outside of Bitcoin applications that were made insecure because of this vulnerability. But one of the first communities, if not the first community to notice this issue, was the Bitcoin community. Exactly because like when you have money that is directly tied to the randomness that you're able to provide, then it becomes like a huge issue, right? You're financially incentivized to find these issues, to report them, and to upgrade, whatever library or wallet that you're using, so that you can, be on some good de facto standard. And they have, some other things here. Oh, so here we go. Back, you always see things coming back to random dev urandom. See, this says the TLS and SSL connections were okay because they didn't seed with this. And as we do see, they seed it with dev urandom. Going back to like, usually if you need any randomness on some operating system, there are operating system calls you can make to get that randomness. And you don't really need to use a lot of these third-party libraries, especially if you're on Linux or a Linux-based system. Dev urandom is typically the way to go. And here they glaze dev urandom a little bit more here. Developers who use JCA for key generation, signing, or random number generation should update their applications to explicitly initialize the PRNG with entropy from dev urandom or dev random. Anything more important here? Developers should evaluate whether to regenerate cryptographic keys or other random values previously generated using JCA APIs, such as secure random key generator, key pair generator, key agreement, and signature. So all these, were affected, and applications that depended on these were kind of deemed insecure at that point until they updated. So now we can look back at Bitcoin and we could ask ourselves, how does the wallet in Bitcoin Core, the Bitcoin Core repo, source randomness to generate keys? So a lot of people say Bitcoin Core should be, your de facto wallet. And if you want to be the most secure you could possibly be, just download Bitcoin Core and use that. Well, now we can look at how they approach randomness to generate their keys. Does anyone have any guess or know how Bitcoin Core generates keys or sources the randomness? Yeah. Not far off. You see, there's a pattern here. Yeah, dev urandom is very important.
Does
But
dev urandom exist on Windows?
no. But going back to like this whole system call thing, there are other system calls you can make that Microsoft provides. That
Trust this somehow.
yeah, whether you trust it or not, that's a separate. And what was that?
I was just asking if there's some type of hash or a reverse of a hash.
There is a hash. Yeah, so all these, we're going to go over it, but like all these little pieces of randomness that you can collect are actually put into a hasher for SHA-512. And I have screenshots of the code here, but like, I could also just like look through it a little bit afterwards with you guys so you can see how it actually looks in the source code. But to understand how Bitcoin Core sources randomness, I have this chain of methods that are called so that you can kind of like follow like what happens when you use create wallet. So if any of you guys ever use Bitcoin CLI, you type in like /Bitcoin -CLI, and the first thing that you do if you're going to hold any funds on your Bitcoin core application is you have to make the RPC call to create a wallet, and you give it some name. And then this create wallet kind of spins through all of these different files and methods. Create wallet, C wallet create, set up descriptor, script pub key, mans, which are like managers, and generate random key, make new key in key.cpp. And finally, we get to like the actual good bits, which are the get strong rand bytes. Now, Bitcoin Core has a lot of random methods. I don't know if you could see all of these, but this is a comment that's actually in random.h. And a lot of this was written by the genius, Peter Woolley, Woolla, or Vola, I think is how you actually pronounce it. I always say Woolley or something like that. Woolla, I think that's the closest I can go. But he's written like a lot of the cryptographic code in Bitcoin. And if you look all over this file, he's the last person, and maybe the only person, who's touched a lot of this stuff. But the random functions that you have available in Bitcoin Core with their own random function implementations are getRandBytes, getRandHash, getRandDir, as well as construction of fast random context objects, perform fast seeding consisting of mixing in. Then he kind of has like all these sources of randomness. And depending on how much randomness you need, it takes from different sources. So here he talks about sources you could use to get like fast seeding, or to make seeds that are like somewhat random, but don't need to be like super secure with the utmost security. Because when the more randomness that you can guarantee correlates with the amount of time that you spend like measuring some source of entropy. So here he has like fast ways, and fast ways that he goes to source randomness is a stack pointer, indirectly committing to calling thread in call stack. So there's a timestamp, again, used as part of the sourcing for randomness here. So a high precision timestamp, blah, blah, when available, C++, high resolution clock, otherwise. 64 bits from the hardware RNG when available. So it checks if you have like, some kind of hardware device to generate random numbers, and it'll take from there. Again, this is like for the fast seeding, the fast entropy. These entropy sources are very fast and only designed to protect against situations where a VM state restore/copy results in multiple systems with the same randomness. Fast random context, on the other hand, does not protect against this one created, but it's even faster and acceptable to use inside tight loops. So again, like he's trying to define different levels of randomness that you might need and trying to explain the context in which you might want to use them, saying, hey, like you could use some of this stuff here, but fast random context does not protect against like synchronization of like other computers that might be in the same state, and your randomness will not be secure.
I thought a timestamp would not be random.
It is not good as a single source of randomness.
Okay.
It is used, so I'm going to show like a little bit of it as well, but usually these are used in conjunction with like other things. So in this case, it was like a stack pointer and a high precision timestamp and 64 bits from the hardware random number. Exactly. Yeah, and like there's like things called like mix-ins in the code where you try and mix them all together. And also even this is the less secure way to generate things. The more secure is to get strong random bytes, but all these are just ways to get fast entropy. And when you get more secure entropy that's needed for generating your keys on Bitcoin Core, you actually incorporate these methods to get fast entropy with your methods for like more security. So here we go. Let's focus on what's used in the wallet. So this is just a zoom in of this part. So the get strong rand bytes function performs slow seeding, including everything that fast seeding includes, but additionally, OS entropy, so dev urandom, which is like within this get random call, and the application will terminate if this entropy source fails. So if it hasn't had the time to initialize, and it does require some time to get urandom initialized, then any calls that you try to make to generate private keys will fail. Because again, these are keys. These are the most important things to you for like running Bitcoin Core. So they try and give you some safeguards to not shoot yourself in the foot if you're going to send 10 Bitcoin to your Bitcoin Core wallet, right? Another high precision timestamp, indirectly committing to a benchmark of all the previous sources, and these entropy sources are slower, but designed to make sure the RNG state contains fresh data that is unpredictable to attackers.
That's interesting that it's using the second high precision timestamp.
Yeah.
I feel like just intuitively it feels like that second one might be a little more predictable relative to the first one type of thing, right? Maybe not.
Well, I guess it depends like how many bits you need, or again, this precision aspect of it, how many they're actually able to record. But generally, like the more precision you can get, the more randomness that can be provided, from that source. And again, all of these alone still aren't used as for part of its source of randomness. So I said, hey, let's look into get strong rand bytes and let's actually see what it calls, what it does. It goes into something called proc rand seed slow, and then get os rand. And going back to the fact that different operating systems have different ways to source randomness, although like dev random is or dev urandom is a great way to source entropy on Linux. There are other ways on other operating systems. But yeah, this is the flow for get strong rand bytes. And then here in the seed slow is where I decided to start to show you what happens here. You have this like seed fast, and it puts things into the hasher. You have this get os rand, puts stuff in the buffer, and then you use the hasher, which is like a SHA-512 hasher, to go and like start writing things, to like even this buffer, and you seed events. Again, a whole bunch of other ways to generate randomness into the mix. You give it the hasher because you just say, hey, like hashes for me. And seed timestamp, so high precision timestamp. And you can view this all on Bitcoin Core. Again, Peter Wolla, very good at cryptographic thinking and all that.
Is he there in the Satoshi days? Or?
I don't know when he joined the project. But I feel like most of the core parts of Bitcoin Core that you want to be correct are written by him. So,
do you know what it means?
oh, it's dying.
Do you know what it means when it says we directly commit to a benchmark of all the entropy gathering sources in this function?
All right, I'm not quite sure what he means by this, to be honest. Timestamp in the fast seeder. So we indirectly commit to a benchmark of all the entropy gathering sources. Maybe he's saying like the timestamp of seed fast, since like this calls a different like seeding method that is similar to this, just with more sources. So maybe he's saying, oh, we commit to having used the seed fast and the seed slow by incorporating both timestamps. I don't know. That's just my guess. And yeah, my battery, like you were saying. Oh, okay, awesome. Thanks. 9%. So
We'll go fast using all the AV
yeah.
stuff.
I mean,
insecure generator to go fast.
right, yes, insecure fast. But luckily, I don't have too many slides, so don't have to worry. But yeah, this is it's pretty cool taking a look at this. Each operating system has its own unique way to generate randomness. Again, from Bitcoin Core, we have this get os rand. And this is all in random.cpp. This is someone else. He used to be a maintainer of Bitcoin Core, and large chunks were written by him as well. And get os rand, and here you can see like get random, for example, and you have these macros that are like, oh yeah, if this is Windows, then you do this. You start using like their crypto acquire context W, and if you have like get random, and again like get random is usually from Linux. It's a way to get entropy from dev random, then you'll use that. You have like macro specified for OpenBSD. And this is like, again, the actual function that's used. So depending on the operating system you will have different randomness even at that level. So in the Linux distribution of Bitcoin Core, I spoke about get random. An important thing to note is that we're processing the data through the hasher, which is performing SHA-500 or 512 hash. And this is from proc rand, which I didn't show before, but it's like right after, it's called from get strong rand bytes. So even the higher level version of proc rand, it makes this determination depending on the argument that's passed in for RNG level. And if you do slow, then you go into seed slow versus seed fast, which is maybe the more insecure way to source this randomness. And you have like this mixed extract, and you want to make sure like everything's working okay. Yeah, I think that's all mentioned here. So what is a big takeaway when discussing randomness? And I have a big takeaway. The only thing predictable about life is its unpredictability. So if there's one thing that we have seen from these sources of randomness is that usually you want to source randomness from some physical process that you don't understand. These aren't purely generated from algorithms. You'll always need some kind of outside source or some outside thing that is above your level of comprehension to predict the patterns for. Which is why I said the only thing predictable about the life is its unpredictability. This is not being able to comprehend things is beneficial to keeping our data secure and all that. Yeah, and some memes, of course. And final thoughts about randomness. Randomness is an adversarial game, and the only thing that has stayed constant with our evolution of random generation is our drive to find more patterns and discover more of the unexplained. So as soon as we find a break in a source of randomness with respect to a pseudo-random number generator, we typically have other random functions that we've generated. So all is not lost when you have one vulnerability in one of the algorithms. I mean, even if things like the SHA-2 class of hash functions, like SHA-256, we have other hash functions today. We have like SHA-3, which is like this sponge function, and it's like we're always making advancements in the case of generating randomness. It's not a fixed thing, and it's of course adversarial because people love to break these pseudo-random number generators. But we'll always have things that we can't explain, and as long as we have those, we're good. The only thing that people seem unable to predict are the minds of all other beings, at which point randomness and cryptography become a moot point. So, people are random. You source randomness from people, like, again, like when you, even like those mouse movements, I said if you have enough precision, then those decimal bits at the end start to look random because no one is intentionally trying to move their mouse to like 0.000001 of an inch. It is kind of random up to that point of like your muscles, like your table, the friction, the material of your mouse. So there are things that humans do that can be used as a source of randomness outside of like the human actually willing that to be random. And whether it be the threat of government pressure, new mathematical developments, or advances in technology, you can rest assured because, again, humans are a great source of randomness. And as long as there are humans with unpredictable free thought, there will be randomness. And as long as humans are able to think and engage in individual and sometimes coordinated thought, there will be privacy. And that is the end of understanding Bitcoin Source 21 and the end of the series for a bit, maybe coming back for season 2. But yeah, that's that's all I have. Yeah. Thanks. All right, so I'll stop the stream, and we can all converse.